How satellites stay in orbit. Look up at the sky. Somewhere above you, satellites are moving at thousands of miles per hour. Not hovering. Not floating still. They are constantly moving. And somehow, they never fall back down. Or drift away into space. They just keep circling the Earth. Which sounds stable, but it is actually a continuous balancing act. So today we are going to walk through how satellites stay in orbit and why they are technically always falling, just in a very controlled way. Chapter 1: The basic idea. Satellites stay in orbit by balancing motion and gravity. Gravity pulls them toward Earth. Their forward motion keeps them moving sideways. This creates a continuous curved path. Chapter 2: Gravity's role. Earth's gravity pulls everything toward its center. This includes satellites. Without motion, a satellite would fall straight down. Gravity is always acting on it. Chapter 3: Forward velocity. Satellites move forward at high speed. This is called velocity. The speed is carefully chosen. It allows the satellite to keep missing the Earth as it falls. Chapter 4: Falling around the Earth. Orbit is often described as falling around the Earth. The satellite is constantly being pulled downward. But it is also moving sideways. This creates a circular or curved path. Chapter 5: Launching into orbit. Satellites are launched using rockets. The rocket provides the required speed. Once the correct velocity is reached, orbit begins. The satellite continues moving without propulsion. Chapter 6: Different orbits. Not all satellites orbit at the same height. Some are closer to Earth. Others are much farther away. Orbit type affects speed and coverage. Chapter 7: Orbital speed. The lower the orbit, the faster the satellite must travel. Higher orbits require less speed. This balance keeps the satellite stable. Speed is critical to maintaining orbit. Chapter 8: No air resistance. Space has very little atmosphere. This means minimal air resistance. Satellites do not slow down quickly. They can stay in orbit for long periods. Chapter 9: Small adjustments. Satellites may need adjustments. Tiny thrusters can change position or speed. These corrections keep the orbit stable. They compensate for small disturbances. Chapter 10: Gravitational influences. Other forces can affect satellites. The Moon and Sun exert gravitational pull. Earth's shape is not perfectly uniform. These factors can shift orbit slightly. Chapter 11: Orbital decay. Over time, some satellites lose altitude. This is called orbital decay. It can be caused by slight atmospheric drag. Eventually, the satellite may re-enter the atmosphere. Chapter 12: The bigger picture. Satellites support communication, navigation, and observation. They rely on precise physics. They remain in orbit through balance. They are part of modern global systems. To wrap up, satellites stay in orbit by balancing gravity, pulling them inward, and forward motion carrying them sideways. This creates a continuous path around the Earth. Speed and altitude determine how the orbit behaves. Small adjustments maintain stability over time. They remain in orbit by constantly falling, but never reaching the ground. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.